really what we're looking at in this session is, as the second largest ocean, the Atlantic Ocean is a major resource for the nations adjacent to it, as well as from far from it. And the Galway and the Belém statements were signed to intensify collaborative partnerships towards common goals. And several studies have been conducted by a number of institutions, and they all indicate that there are huge disparities among coastal nations in terms ability to generate and process knowledge derived from the ocean. And the major limitations are around access to the ocean and the ability to manage and store data derived from the ocean environment. Seagoing research is very expensive, and as such, there has been several scientific innovations to implement traditional ship-based activities. And in this, the panelists are going to focus on innovative ways of sharing infrastructure and data to advance the commonly shared goals of unlocking the Atlantic Ocean secrets and sustainably manage the Atlantic Ocean and as a whole. And the use of autonomous technology coupled with remote sensing is proving to be vital at this stage. And to kick us off for this panel discussion is Martin Visbech from GeoMar in Europe. Over to you, Martin.
Thank you very much, colleagues. And I would like to quickly share 2, maybe 3 slides with you. It is so wonderful to see all the youth ambassadors speaking about the opportunities and the future and the discoveries that we have around the Atlantic. What I would like to share with you, the youth ambassadors and all the rest of the community, is some of the opportunities that we already have for working together in the Atlantic Ocean, that is all the Atlantic, North and South and tropical Atlantic, how to better and more systematically observe the ocean that we all passionately care for, that we want to protect on the one hand, but also sustainably use on the other hand. And we have benefited from the Belém and Galway partnerships, but also for some support from the European Union to start a program that we call Atlantos. And it's an observing system activity that brings together all the different types of observing that we do around the Atlantic Ocean, North Atlantic, Tropical Atlantic, South Atlantic, by working together. And we're using what we call the Framework of Ocean Observing. It's a strategic document that talks to us about how we can best do that. But what we really established is another way to think about that. So on the one hand, we in society need information around the ocean for safe navigation, for food production, fisheries, for also protection against hazards, but maybe also informing the use of the ocean in a sustainable way, but also things like tourism. Now, these requirements give us tasks to go into the ocean and observe it with various networks, what is happening in the ocean. And then that information is very technical. You see some pictures down here of ships, robots, satellites, various type of airplanes, robotic systems, drones, and so on, but also citizens coming in. And this information then gets processed to data systems and generates the information that we want. And in Atlantos, the program, we are really facilitating shared access, shared data sharing, and in that sense, benefit sharing. And we do that in 2 mechanisms. On the one hand, we work with the Global Ocean Observing System that we're going to learn a bit more about how to implement our ambition in the basin, the Atlantic basin, that is North, South, and Tropical Atlantic on the one hand, but also focus on particular areas as they pertain to carbon uptake, for example, mitigating the impact on sargassum, more in the tropical belt here, but also thinking about how we can use animal tracking to predict where animals, large species go, but also smaller ones. We also want to really have a better idea of how climate services can be supported by the kind of work that we do, for example, by looking at the overturning circulation. And last but not least, supporting ecosystem-based management, in particular around the upwelling regimes of Africa. Here's the Benguela and also the African system around Mauritania, Senegal, Cape Verde, Morocco. And I think this is a wonderful way to work together. And we've really facilitated that interaction between the communities, between the countries, and to facilitating some more data sharing and so on. But in addition to that, what Atlantos can do as a program that supports the connectivity on observing, I also want to show to you on my last slide that we're also working on the much more radical working together in a sort of digital sense. And here what we're trying to do in what we call these digital twins of the ocean framework is to take the observation that we have, look at them through the lens of data systems, and that involves most modern supercomputing, but also artificial intelligence, combining all the data, and then that comes together as being part of what we see the benefit sharing. And it's here through access things like EMODnet, the data holding, the Copernicus Marine Services. These are European actions, but we have similar things happening in South Africa, ambitions in Brazil, Argentina, and really bringing that to the citizens through cloud computing and through access. And these digital twins, I think, are allowing us to make that data and information explorable, discoverable, usable in very new and innovative ways. So we're really harnessing the power of the digital revolution, which is around us, to also deploy it to improve data management, improve planning, improve knowledge about the ocean, very much in the spirit that we're discussing here. And I'm quite looking forward to discuss that more with my panelists. Thank you very much.
Geez, thank you so much, Martin, for that. I think right there at the end, when you're saying the activity of observing, and then we translate it to data, then we translate it to knowledge, and then we contribute to decision making, and really the observation of the ocean then begins to reach the people and really impact the people. Thank you so much for that, Martin. I'm going to move on to Sandy Tomala, who is the senior researcher at the Council for Scientific and Industrial Research in Pretoria, South Africa. Over to you, Sandy.
Hi, thank you very much. I'm just trying to get rid of it. Can you see everything fine? Okay. So I'm going to be speaking today from Science to Societal Impact and Integrated Research.
Sandy, sorry, do you have a PowerPoint presentation? No.
Yes.
Because I can't see it. I can't see it yet. Could you try share it again?
There we go.
That's it. Thank you.
Oh, my apologies. Okay, so I'm talking from the Southern Ocean Carbon and Climate Observatory, and my presentation today is from Science to Societal Impact, an integrated research, technological innovation, and HCD approach. So first off, to start, why the Southern Ocean? So essentially, it's been termed the climate flywheel of the planet. And to be honest, I didn't really appreciate what that meant or what a good terminology that was for describing the Southern Ocean until I Googled it recently. And it described the flywheel as the inertia of the flywheel opposes and moderates fluctuations and stores excess energy. And that goes to show what an appropriate description it is of the Southern Ocean, in that the Southern Ocean takes up 50% of the ocean CO2 uptake. It takes up 75% of the heat that's generated from the anthropogenic CO2 that's accumulating in the atmosphere, and 30% of the global ocean primary production. However, this important role that the Southern Ocean is currently playing is expected to change with changing climates, and this will impact climate predictions, climate risk, the effectiveness of mitigation strategies, and of course, the economic cost and adaptation plans. And the problem really is that our current Earth system models are not particularly good at being able to characterize the seasonal cycle of the CO2 flux in the Southern Ocean. On your left is a figure where all the colored lines are the CO2 flux between the ocean and the atmosphere for the subantarctic zone in the Atlantic Ocean, and the black line represents the observations. So it's quite clear that the models aren't doing a particularly good job. And a major source of uncertainty lies in the spatial and temporal sampling biases. In particular, the Southern Ocean is very inaccessible in winter and hard to get to, and so there's a seasonal bias. And also, there's a temporal bias in that it's becoming more and more evident that the processes that are happening in the Southern Ocean that are controlling the flux are at small temporal and spatial scales, and that these aren't characteristically well resolved with measurements. Finally, there's also issues with model parameterization, in that a lot of the Earth system models aren't really refining processes that are specific to the Southern Ocean, particularly when it comes to phytoplankton and how they react to light and iron and their environment. And finally, resolution. It is a necessity for Earth system models to have coarse resolution, but as I mentioned earlier, a lot of the processes are happening at fine resolution, and this tends to bias the model's predictions. And this highlights a need for autonomous, remotely sensed, and modeling techniques, because these are all able to address the very relevant temporal and spatial scale gaps of our knowledge of the Southern Ocean CO2 system. And this is where SOCO comes in, the Southern Ocean Carbon and Climate Observatory. We have a multidisciplinary approach to addressing the role of the Southern Ocean in climate change. And we have a wide range of technically advanced facilities. I'm just going to run through them quickly. We have a bio-optics facility, a robotics and profiling facility, CO2, trace metal sampling and analytics, a biogeochemistry facility, that's one of our new photosynthetrons that we recently developed and manufactured locally, and we have advanced supercomputing capabilities. From a research perspective, SOCO science is framed by ocean physics and how that physics interacts with CO2, heat, and the biological carbon pump. And our research is defined by three primary aims that link the science to societal benefits through models, long-term observations, and data products. And just to go through these three aims, the first one is advancing process understanding and model parameterization. This is where we really look at very carefully considered multi-platform integrated process studies and seasonal cycle experiments that typically use research vessels like the SA Gullis 2 and autonomous platforms to improve our understanding of fundamental relationships in the Southern Ocean, and then we use those to parameterize that understanding to parameterize the models with Southern Ocean specific knowledge. The second one is advancing models and modeling, and here specifically is where we represent subgrid scale ocean circulation dynamics in Earth system models. So we take our fine scale understanding of the physics and we parameterize it into coarse scale resolution so that it is represented in Earth system models. And the third one is advancing observational-based constraints for models. And here we have an interactive iteration between machine learning, statistics, and a wide range of scale-sensitive observations to come up with data products that can be used to constrain the models for improved future predictions. If you look at our technological innovation, essentially SOCO pioneered the use of ocean robotics in South Africa and the Southern Ocean, in fact. And this is because of our scale sensitivity approach. And these platforms have served to provide to allow us to sort of launch an innovation applications beyond SOCO science. And we've started an R&D plan for new capabilities for potential and important spin-offs in ocean services, sensor development, and exports. I'm just going to mention three quickly. We have the development of an acoustic wave glider, which was used for fish stock assessment at a fraction of the costs of ships. We have the development of a high precision PCO2 sensor for ocean, atmospheric, and terrestrial application that is an order of magnitude more sensitive than the sensor that was available from the US. And we've already sold 2 of these sensors. And then we have the adaptation of a wave glider to include a hydrogenerator, which specifically allows our gliders to operate in the low light environments in the Southern Ocean in winter, which helps us to close that seasonal bias by collecting year-round data, including in winter. And then last but not least is a human capital development. SOCO's technologically advanced infrastructure provides an HCD platform for training a new generation of scientists and engineers in multidisciplinary skills. We've made a big impact in the national priority of HCD by graduating 42 students over the past 10 years. And we also have a very strong commitment to transformation, and our success is becoming evident over the last few years, where we have an 85 to 100% dominance in HDI. We also have a good gender distribution with 56% female students if you go cumulatively over our last 10 years. And then my last and summary slide is just to say how science goes through to society value chain. So if you start up here with the technological innovation, this is where you have your observations and your technological innovation, which through the science discovery, you get to have your analysis and your modeling and your data products that allow you to look at prediction and risk, which feed into assessment and government and policy for the impact in the societal benefits. Thank you very much.
Sandy, thank you so much for that. I just wanted to maybe very quickly, just in 1 minute, you say that you guys have already sold 2 of those robots. Who are you guys selling them to? Is it other researchers? Is it the industry? Who else could potentially benefit from such infrastructure?
But those particular infrastructure was not the robot, but the sensor that we put on the robot, which is a CO2 sensor. And yes, those were to German colleagues measuring similar fluxes, but there is also an interest for terrestrial applications on CO2 flux towers. So it doesn't have to be for marine application, it can also be for terrestrial. So there's a lot of interest in the CO2 world, both in the terrestrial world and the ocean world, for very sensitive CO2 flux sensors.
That is so cool. Thank you so much. That's so interesting. And I mean, if I had more time, for me as a biologist, I'm really interested when I hear about things that generally aren't in my radar. And what would be interesting for me is to hear this role that the ocean plays in taking up 50% of the CO2 and 70% of excess heat, and what a mere 1 degree increase or 2 degree increase in our temperatures could have on that role. But I mean, I think I'm going to move on, and if we have just a little bit more time before the next session, I think I want to come back to that question because I'm really interested. Thank you so much, Sandy. That was so informative. Great work. Thank you. Next up, we're going to Jose Henrique. Jose Henrique, who is professor for the Institute of Oceanography, Federal University of Rio Grande in Brazil. Thank you so much, Jose. Over to you.
Thank you, Tulil. For me, it is, can you see me?
I can see you, yes.
Good. For me, it is a pleasure to be here today. I've been involved in many of the steps that have led to development of this All-Atlantic cooperation. And it's great to see it that we're really moving forward and having new life brought in with the youth ambassadors and with all the activity that's going on. So I would like to thank the Republic of South Africa, the European Commission, and the Brazilian Ministry of Science and Technology and Innovation for the invitation of having me here. I will share a few slides with you if I get the correct one right away. Of course, I cannot see the one I want right now, so just bear with me for a second. Can you see the slides now?
No, not yet.
Something that have happened different from what we had planned before here. So is it showing now?
No, not showing yet. Not showing yet.
So I will show it in a different way. Just a second. I'll do it this way. Okay.
We can see it now.
Yeah, you're going to see it with the frame, but I'm sorry. For some reason, the full slide presentation mode did not come in. But you can see it now, right? So what I want to say is that I'm a professor at the University of Rio Grande in south of Brazil. So we are exactly at 32 degrees south, the same latitude of Cape Town. So if you're in Cape Town right now, go out the window, you can wave at me. There's only the Atlantic Ocean embracing us. For this event, we were asked 2 questions: how to improve sharing of infrastructure, and how best do we share marine technology between the Atlantic community. So I went on and I looked at what does it mean to share? So I found that actually there are 2 definitions for sharing. The first one can be a portion of a larger amount, which is divided among young people. So this is what they call the my model. I have my toy, like as a researcher, I have my preferable tool, in this case, a multinet for plankton sampling. And I can share that with my colleagues. Well, you all probably are aware of this type of sharing. This type of sharing, when I owe something and I lend it to someone, has many problems associated with it. You know, of course, I can share that, and I can have it with different people, but there's always some trade-backs here, some pitfalls. So this is not probably the best way to go. I found that there's another definition to share, which means that a large amount to which a number of people contribute to. And this is what I call the hour model. And as an example, I would like to give you a case that we have here in Brazil, which I think it could be very significant for our research infrastructure in a whole all-Atlantic studies that we want to conduct in the future. All the marine sciences in Brazil, and especially oceanography, the students are required to take some time of onboard training. This is very hard to do individually at each university. I mean, not all the universities have a research vessel. So you need to have, you know, a set of vessels that could apply to all of them. So some time ago, technical group got together to try to solve this problem. So what they did, they decided that we needed, instead of having a ship for each of the universities, we would have one vessel that would supply and be shared among a group of universities. So this experience, called the Experiência Embarcada, the on-board experience, actually comprises in having one infrastructure that is not owned by a single institute. So it is managed and co-owned by several institutes. So in this case, the Ciências do Mar 1, the first vessel that was made available, you know, it's located in the south of Brazil, and it is shared among all the institutes in the southern part of Brazil. So my own institutes and other institutes in this region benefit from this one infrastructure. We have already 4 other of these vessels being shared in Brazil, one in each region. So we have one in the central region of Brazil, one in the northeast, and one in the north region. So these vessels are already available there. They are very important infrastructure that can be shared among a group of institutes in order to develop their studies, to improve capacity building, and to conduct all sorts of studies in one region. So this is the model that I think we could have for the All-Atlantic in case we want to have a real collaborative research infrastructure facility. Both models have pitfalls and advantages. In the My model, we have a single ownership, which means single responsibility. The costs are always on the owner of that infrastructure. Like if I have my net, I have to do all the maintenance of the net. If the net gets lost, I am the only one that's going to be in trouble for that. And normally in the My model, the collaborative products that we get, they are induced by coercion. What I mean is that if I'm lending something to you, I would expect something in return. So there's not a voluntary collaborative effort. But on the other side, in the Our model, when we have a co-ownership, the responsibilities are shared, the costs are divided, and we, at the end, we'll get genuine collaborative products where everybody is part of the whole. So this, I think, it's the model that we should look for if we want to have collaborative research infrastructure in the Atlantic. I think, like it was mentioned by Moniba Isaacs yesterday in her opening address, to this conference, it's very important that we decolonize research. So with this our model where we have a co-ownership and we really share infrastructure, I think this would be an important step forward to decolonization of research. So I would like to stop here. Obrigado to all of you.
Jose, obrigado to you. Thank you so much. And I mean, I'm seeing all the panel members, especially coming in and agreeing with you in your statements and preference for the our model. And I think as a researcher myself, I think I would have gotten so far if as a research community, we were using that model as opposed to the model that says, if I use your equipment, you will get authorship in my paper, or this will happen, or I have to pay for this. You know, I think would go so far, and it would, you know, really just end a lot of the challenges that we have in research, especially when we talk about in places where resources are limited. And I think that should just perhaps be the standard way of conducting research, don't you think?
Well, yes, I fully agree. I think we share the same you know, the same questions that you were just mentioned, the same anxieties. You know, we have very, very limited resources. Like the net I showed to you, it was lost at sea. And that, you know, that's 25,000 euros, which for us, it's a lot of money. We only managed to get a new net like that 5 years later. So it is really important that we have a sense of sharing it in a different perspective.
Thank you. Thank you so much for that, Jose. Thank you very much. I think that was really intriguing for me. And I think when we speak about the human element in research and the human elements in science, it's thinking beyond the data that we're going to get, but it's taking a step back and looking at how are we all going to be able to generate the data, and then we can all co-implement, we can all co-own, and you know, collaboration is key. Thank you so much for that very intriguing presentation. Thank you. I'm going to move right along now to, I hope I pronounced this name correctly, Genevieve Pechot, who is the Director General for the Canadian Hydrographic Service in Canada. Over to you, Genevieve.
Yes, hello. I think the video needs to be started. I can unmute, but I can't start my video.
Rufilwe, can we assist with the capability to start the video capability?
Thank you. Yeah, it says the host has stopped it. And mind you, I don't have slides, so I can talk, but it might be good if the video was unlocked. And maybe I can get started while that happens.
I think that's best. I think that's best. We can get started. It puts you onto video. Thank you.
Yesterday, we heard about the importance of connecting ocean scientists from different disciplines, connecting across the Atlantic Ocean, connecting science results with society, connecting to decision makers. And we heard about exciting work where this is happening. I think we can all agree that data is a starting point of information, of conversations, of connections, of decisions. There we go. Excellent. So my remarks today, we're going to focus on data. And I wanted to draw on examples from the world of hydrography, which is my world. The data that the hydrographic organizations collect are fundamental to starting to understand our oceans. In particular, bathymetry allows us to have a picture of what's physically at the bottom of the ocean, to create maps and charts, to better understand the shape of the seabed, which is critical to understanding ocean circulation patterns and understanding marine ecosystems and marine life. And finally, this data supports planning for the use of the ocean. So this is why I wanted to use some examples in this world. So when we talk about sharing data, and using data, we first need to talk about data standards. And that is something that we collectively need. Through the International Hydrographic Organization, the hydrographic community is making great progress in the development of new standards for digital hydrography, what we call the S100 standards. They will make it possible for us to use different types of data together and display them on the same system, the same way that we can see different types of information on GPSs in our cars. This will allow the data to be delivered to a machine. And this is what we're going to need to provide to support autonomous vessels, which are happening now. We'll need to be able to provide information that machines and autonomous vessels need without having a human eye interpret it. So on the navigation side, the international community has been working for many years to determine what the data standards should be. And we're now working with other groups who have different types of data, so the Coast Guard and meteorological services, to make our standards work together. So we're going beyond what we know in our world and looking at standards across different disciplines to work together. And what this means practically is that a pilot or mariner navigating a cargo ship into the port of Halifax in Canada would be able to access all the data he or she needs. Hydrographic data, which lays out the path that the ship needs to take, weather data, other data related to navigation aids, and display this on equipment to help them navigate safely around the port. And over the next few years, what we're going to need to do is to ensure that ships navigating across the Atlantic, from Halifax to Saldanha Bay to Sao Paulo, have a seamless access to these data services across the Atlantic. So if we take this further, and as we look at research around the Atlantic Ocean, how do we ensure standards from different communities, whether it's around microbiome, resources, to connect with our standards so that we can easily use this data together to support decisions around the blue economy. Going back to the example of the autonomous ship, which is navigating our coast, what if we could include information on the location of the whales, for example, so that the ship can avoid a collision? Can we pull different types of data when they consider decisions around the seafloor where there are competing interests? So once we agree on standards, what about making that data available? So 2 weeks ago, the IHO Assembly, so the International Hydrographic Organization Assembly, approved a 10-year roadmap to implement the new S100 standards. And several countries, including Canada, are now conducting sea trials to see how those standards can be applied. How can they be transferred from the data holder, in our case, all the way to the navigator? And we've been working in this past year to with software developers in Canada, data distributors in Norway, and pilot users to test how these data can be provided through the cloud. Pilots navigated with 2 instruments, one with the regular data, one with the new data. It's an innovative way for mariners to access data. Now, if we go to look at a broader range of users, we've just released all of the bathymetric data we have at 10-meter resolution. It's what we call NONAD-10 or non-navigation data. We've done this as a pilot so that all users can be invited to give us feedback on how this can work. And when you start looking at the data, you see all the data gaps that we have in Canadian waters. It's not unique to Canada. Only 20% of the world's oceans are mapped, and certainly the Atlantic Ocean is not fully mapped. This is why Seabed 2030 project was launched. It's a project aimed at bringing together all the data we've got, filling the gaps to make sure that we have what we need to support the blue economy. I'd like to talk about one last example, which is talking about citizen science. We heard a little bit about it yesterday. Work is underway right now to test the use of simple yet sturdy instruments, which you can hang on the back of a small motorboat or on board a yacht to collect data that is good enough quality to use. And in Canada, we're working with a network of universities called Comran to further develop this concept. We did a first project in the Canadian Arctic using what we call hydrobombs, which were provided to Inuit communities to show that the concept could work. The next step now will be to show how that whole data cycle, the collection of data in the community, to archiving that data somewhere where the community can use it, and to reusing the data by the community. The equipment is simple and robust. We provide the standards, but then the community can own the data and decide how they use it. And this, I think, takes citizen science one step further. It becomes a community-based science where the community can get the data they need to manage their local fisheries, marinas, or other ocean-related activities. And you can see how this could enable Indigenous communities to use the data with their traditional knowledge in making decisions. So I'd like to conclude here with saying it all starts with standards. This enables us to integrate different types of data, and this can then support conversations connected. Thank you.
Thank you so much. The idea of data sharing is an interesting one because we always talk about sharing data, but we never really hear about how that data is going to be shared, who's going to have access to that data, and what formats is that data going to be. And I think what you're bringing to the fore here is that in a multidisciplinary community or transdisciplinary community, that is the All Atlantic Oceans Research Alliance, you have a standardized way, or you create standards that enable everybody in that community to have access to data from across different disciplines. Is that correct?
Yes, that is.
That is so awesome. And then at the end there, you also say, which I think is very interesting, the concept of sharing and opening the data up to the community. You archive that data and you share it to the average person. Now, I think that's really interesting, but what would that entail? I read publications sometimes, and if it's an experiment I've never done before, understanding the way that the data is packaged can take me a bit of time, even as a person who is in the research community. So what strategies would you propose would be best to capture this data for the lay person?
So another question, and so the community has a place. We have an international database actually hosted in Boulder by our colleagues at NOAA, where anyone can contribute the symmetry. However, if you're not an expert user, it may not be so easy to go there and grab the data. And so what we're exploring is, can we have local hubs where if they're collecting data, yes, it goes to that international database, but also a local hub where you could then reuse the data. And then it comes down to what applications do you develop? What kind of tools do you develop to make it easy? And I think the tools development starts with what questions are you trying to answer? And I think that's why we're going to pilot this with the view of looking at how you could then make that work and then broaden it to other communities in Canada.
Here's another question, but I think I'm going to move on to the next speaker. And I think at the end, I'd like us to answer this question, all of us that's in this panel, perhaps if there's time, is to think about what do we think that the community would want to be using this data for? As scientists that generates this data, that collect this data, create the standards for the data, what do we think the layperson needs this data for? Because I think at the back of the availability of data, as people that create it, we make the assumption that everybody wants it and everybody needs it. And I think we need to start finding ways to communicate to people what data can do. So the question to everybody in the panel is, what do we think the community is going to want to do with this data? But I'm going to move on to the next speaker. And the next speaker, thank you so much, Genevieve, for that very thought-provoking conversation. I'm going to move on to David Legler, who's the director for NOAA, or NOAA, Global Ocean Monitoring and Observing Program in the United States of America. Over to you, David.
Thank you, Jaleel, and I appreciate greatly. Thanks so much for the opportunity. What an exciting morning to hear about from the ambassadors, and I appreciate especially the comments from the previous presenters on the panel this morning. For more than 20 years, NOAA has been at the forefront of ocean observing technologies and capabilities and supporting the development of a global scale ocean observing system, including the Atlantic Ocean, that provides knowledge and services near as weather, climate, fisheries, and resilient coast. The Atlantic is probably the most comprehensively sampled ocean, and I think progress on observing and collaboration in the Atlantic has benefits in all of our oceans. As the most densely sampled ocean, it provides a great test bed for asking and investigating questions, such as what's the role of the Atlantic Ocean in weather and climate events, ranging from hurricanes and cyclones to multi-decadal changes. What are the impact of those changes in the Atlantic Ocean on issues that matter most to people around the Atlantic, fisheries, those impacted by weather, coastal communities impacted by rising sea level and ocean acidification, and even ocean economies based on tourism, shipping, and energy. And NOAA is very interested in all of those topics. 3 points I want to make. The first is the importance and role of research infrastructure and partnerships and how they're important to sharing of data and knowledge. So it goes back to some previous panelists' comments. Those research projects and infrastructure include things like international observing programs such as Argo, where shared planning, shared platforms, and shared data really have revolutionized our knowledge about the global oceans. Multinational projects are also important. A lot of those are research-based, and they're very creative in their arrangements of shared responsibilities, planning, shared credit for publications or discoveries, and the knowledge, but they're based really on the desire to pursue challenges of interest to all. And I think we're seeing some examples yesterday of some of those and today. And those are really important. So a few to highlight from NOAA, for example, we support the Parado Ray along with our partners from Brazil, France, and others. And that started off over more than 20 years ago, focusing on ocean and atmospheric climate, but have now been expanded through additional partnerships to look at, for example, they're now equipped with acoustic monitoring receivers as part of the ocean tracking network for pelagic species. There are additional weather and climate sensors on board. And so again, thinking about those partnerships and how those can be used as a platform to build out sharing of knowledge and information and opportunities. As mentioned yesterday, there are hydrographic cruises planned in the Atlantic in the coming years by NOAA and our partners. And there's some great opportunities there for, again, sharing that expensive infrastructure. Other ship-based platforms are also available, whether they be from the Ship of Opportunity Network that deploy XBTs, or might have ships equipped with carbon measurements or measurements that can provide some estimates of ocean acidification. So again, many different examples like that. My second point is about the importance of observational coordination, best practices, and data sharing. It goes to the previous panelist comments. There are many observational activities already underway, and those can be better. Those data can be better shared and better coordinated through sharing of information. One actionable suggestion could be that we, within this community, share more information about ship schedules from the academic fleets, from federal and private corporations that might help us plan more in the Atlantic Basin on what's coming up. And groups like OceanOps can help do that. The development and sharing of standards and best practices are also important. And there are efforts within the Global Ocean Observing System, GOOS, and the Ocean Best Practices community to help develop those and publicize those to help all communities and all practitioners who are interested in this gain from the knowledge of others and help get a leg up on how to do that. And one particular example I would provide about the importance of that is, and particularly of sharing of data, as I've already mentioned, Argo has revolutionized our knowledge about the global oceans, and the key to that was sharing of data. And I think in particular, sharing of that data to communities like the WMO and others who are providing products and services can help, again, add to the value of those observing efforts. One of the projects that's underway now is an effort by the WMO and IOC to improve access to real-time data pipelines to WMO and these ocean services, through a new project called OpenGTS. And I think by doing that and allowing more ocean data to get to those types of communities and those types of organizations, that the products that are freely available from many of those communities will improve for the benefit of all. Third point, I just want to point to, again, the sharing of Atlantic infrastructure platforms. We need to do more of that. I totally agree. Such platforms can cover one or more parts of the value chain, as been pointed out several times. I think we need to figure out how to incentivize multinational sharing of infrastructure. And we just heard an example about lost nets and things. But there are a wide range of technologies available. NOAA has been pioneering use of autonomous subsurface and surface ocean vehicles. We recognize that operating those in remote environments in places that are risky, where benefits might come to more people, that we need to figure out how to have a partnership based on the sharing of knowledge and operations of those facilities. And I think, again, through research projects that could show us how to do that are really important. And so finally, I just want to say that, again, we've been utilizing our engagement in communities like the WMO, IOC, GOOS, and in particular, the Planning for the UN Decade. I think there's some real opportunities and some points that we could benefit from by engaging. And I would encourage others to do so as well, just as we have in NOAA. So thanks to Lulu for the time today.
Thank you so much, David. And I think I want to put you on the spot a little bit, because the data sharing aspects of research and innovation is very critical to decision-making, policy-making, and affects people and the lives of people. And as the research community, do we compete to be the first to discover? And what does that, if we do, how does that impact the time at which the turnaround time for creating policy change and changing people's lives and sharing of data? Or are we saying that we should compromise being the first scientists to publish this data?
I think our perspectives have changed a bit over the last 20 years, where I think in the decades past, we saw that a lot of researchers wanted to hold their data close to them and not share as much for desire out of publications. And I think there is a real, there are some, I think, real genuine concerns, especially for students and young early career scientists who I think deserve a need to utilize that data they collect to publicize. But I think, again, we're seeing that with so much data now being pumped out, there are plenty of opportunities for publicizing. But I think there's also, we have to weigh that need to, publicize that and through that discovery with also just the fact that if we don't get those data out as quickly as possible, they'll be lost. And so the long-term benefit to society will then be lost as well. So I think it's something we have to weigh, but I think the evidence is clear that sharing more data is a key to bigger knowledge gains.
And David, I asked you this because you speak about incentivizing sharing, and I'm interested to hear how you think scientists, researchers, and innovators will be incentivized for sharing their data.
Well, I gave one example in my comments that I think by sharing more of their data, particularly to those who are providing products and services, that by providing those data, that those products and services, even though they might be in a preliminary stage of development, that those products and services can be improved. And even if you're doing data in a fairly remote region of the oceans, I think the vision is by those additional data can improve the products for that region, providing greater benefit. And I would go back to your question about what do the users really need? Sometimes they don't really want the raw data. They want a product that synthesizes a lot of different data together. And so I think we have to weigh, the value of individual data efforts versus a broader collection of data and the bigger impact that can have on products and services.
Okay, cool. Thank you. Thank you so much, David. Great conversation there. Thank you very much. I'm going to move on to our last speaker in this panel discussion, and that's Paula Etala, who is the Manager of Research, Development and Capacity Building, the National Weather Service in Argentina. Over to you, Paula. Thank you.
Thank you. So I will share, hopefully, my presentation here today. I would like to share with you an experience for initiating modestly a sustained integrated ocean observing infrastructure. Observing the ocean in this southwestern corner of the Atlantic has been so far a task performed by time-bound scientific projects and temporary field campaigns. Except for sea level measurements, our community does not contribute to much to global networks. We are aware of this outstanding debt. And now the Pampa Azul initiative is leading by providing coordination, a first ever major effort towards an integrated ocean observing system that can provide the basic and relevant information to the monitoring and research. The working group on ocean systems and monitoring proposed to build on the existing initiatives and networks and to provide a framework for an integrated view across the whole value chain of ocean observations. So adaptive technology, scientific underpinning, target capacity building, and system integration are our key cross-cutting area that we will be taken care about. We need, as we are a small country with little capabilities and little experience, we have to implement a tier plan, taking into account our limitations in budget, our actual capacities and capabilities. We face major challenges here, and this can be shared by other countries willing to take these steps forward. We are in the overall lacking in-house experience on long-term management of ocean infrastructures. Our institutions need a strong advocacy and to be aware for the need of sustainability of ocean observations. The scientific system usually, well, you know, is dependent on the best effort and external funding, temporary funding, and we need to allocate the minimum budgets in the long term in formal institutions. Maintenance and quality assurance have big risks, and the availability of well-trained technicians is, in our case, the most key problem here. And we need urgently to start, while we start acquiring, buying some instruments and thinking on infrastructures, and we have to, at the same time, in parallel, start training our people and providing capacity building solutions to them. And also accounting for the different data policies across all the disciplines and institutions and application areas is a challenge when addressing an integrated system. And also building on the sharing model for instruments that are bought by the program and by the funding of the Ministry of Science, that is the institution behind this initiative. So I hope this experience can be shared and can be taken up by our countries and by other countries that can start contributing to the global science on ocean observations. Thank you very much.
Thank you, Paula, thank you so much for those contributions, and I think in the challenges, or perhaps I should put it this way, I think the beauty of platforms such as this, where we're able to share different ideas and share different strategies, is that some of the challenges that we have, the solutions to are answered, because you share the issue of the availability of trained technicians and managing the infrastructure, and essentially just the funding that is required to maintain this infrastructure that allows us to create policy change and make a difference. And I think there's a need here. I think I am running. I've got like just 1 minute left, and I think I want to bring Martin back to. I saw that he had a comment about the role again to emphasize on that sharing model, and I think perhaps we bring Martin back. But Paula, thank you so much for that contribution, and I think the broader panel community is talking about in the chat how we can better share these strategies and open them up to the whole community of the All Atlantic Oceans Alliance, so that people are able to use these solutions that have already been tried and tested in other settings within the Alliance, and adapt them to the settings that we have in Argentina or in Brazil, in the case of Paula in Argentina, I think. Can I segue back to Martin? Martin, I'll give you a moment there to close us off before we go to a comfort break.
Happy to do so. I can't share my video, so maybe the colleagues can do that while I'm speaking. I really enjoyed the session and all the panelists, and also all the comments that we've been getting. And I think you asked us the question a little bit about, how can we really together benefit from both the gathering of the data, making the information available, sharing of the infrastructure, and sharing of the information, and then bringing it down to what you might call the users or the beneficiaries of that. And I think it is worth our while to reflect on that just a little bit more, in the sense, well, how do we going to generate benefit? On the one hand, in the ocean community, we are realizing, or we're suffering a bit from that, the lay public doesn't fully understand what the ocean means to them. So there's a big element there on what we call ocean literacy. And it starts where, when you go to the beach and you look at the ocean, you see the sand and the waves and maybe not much beyond. So how can we look into the ocean, see what's there, discover, appreciate, explore that? I think this is one of the ambitions where these digital twins of the ocean come in, that really allow you to see the ocean that is there, maybe on platform and technologies or platforms like iPads and iPhones and things like that, or that technology. But at the same time, I think we need a shift in the mindset. Right now, we're looking at the ocean from a research perspective. This is not how we do it on land or on the atmosphere. We take observations on land from niche to norm. We do it all the time, always, because we see societal benefit. And in the ocean, we're still in the niche. It's just a researcher doing it. So we got to go from niche to norm. And I think these accesses through things like digital twin platforms, through the data sharing, and also information products will make a big difference. Now, this is not for Geomar to do. This is not for NOAA to do. This is for all of us to do. So the whole thing that we're advancing here, the collaborative approach to Atlantic research, innovation, information, is what's needed. So somehow we have to make this equitable, shareable, that we can all bring the best foot forward. And I think that is the most exciting frontier that I see ahead of us. And I think the panelists brought that out very nicely.
Thank you so much for that, Martin. And I think thank you very much to all the panelists. What an engaging and what an informative session that was. And I think it keeps coming up a lot, the issue of connecting and interfacing with society and how best we can do that as researchers. And I think as researchers, it's really difficult for us to think from the perspective of the other person and not from the perspective of being the researcher. But I think it's a challenge to all of us as scientists and people in the broader STEM community to think about how best we can really communicate ideas and communicate information in a way that creates value for the average person. And I think with that, we'll take a comfort break, and we will return at exactly 4:33 on my watch. So it's 10 minutes from now Thank you so much for that very engaging panel. I'll see you at 4. Okay, let's make it 4:34. Thank you very much.
So Atlantis is an initiative that brings together various actors which focus on Atlantic Ocean observing. And the idea of Atlantis is to bring together the various activities from physics, chemistry, biology, geology, to really elevate the level of how we do ocean observing for the benefit of society. The achievements of Atlantis is one of community building. So it brings together people from the European countries, from Canada, United States, Brazil, South Africa, but also Argentina and Cape Verde, one community that looks at the whole Atlantic observing system. We've also advanced technology. We're bringing new sensors to the system. We're integrating up more complex, more complete observing technologies. And we use that information to assess how the Atlantic Ocean is evolving and getting a better idea where it's heading.
From really early on in the project, we realized that we needed to add more biological observations into the program of Atlantis. This was really needed to understand the full ocean ecosystem, and also because a lot of the product the society demanded from us really require biological observation of the organisms that live in the sea, the animals, the algae, and all the components actually of the biodiversity of the ocean.
The Atlantis project provides a great step and leap forward in our ability to understand the ocean. The Atlantic Ocean is connected to the rest of the global ocean. Now we would like to use the successes from the Atlantis project and roll that out to the rest of the global ocean and improve the observing system to get that global picture and get a quantum leap in the information and the science we can get from the ocean.
So in Atlantis, the program, we foresee a shift from what at present is ocean observing with primarily a scientific focus towards ocean observing with a focus on meeting societal needs. We also want this program to be transparently open to all potential partners, fishing companies like transportation companies, aquaculture, who have a real stake, a real need in this ocean data that we're seeking to enable.
So my dream for the Atlantos program is that all the nations in the North Atlantic, Tropical Atlantic, South Atlantic come together to engage in ocean observing, because it's those data that we get from the ocean that allows us to make decisions how human and oceans interact in a much more sustainable way. So we're looking for a bright, prosperous and equitable future for next generations.
One of the biggest problems that society faces today is that of climate change, in particular the role of the emissions of carbon dioxide from burning fossil fuels and how these gases are accumulating in the atmosphere and warming our planet. Researchers from the CSIR run the Southern Ocean Carbon and Climate Observatory, which is a South African-born science program supported by the Department of Science and Innovation in support of the Global Change Grand Challenge and the Marine and Antarctic Research Strategy.
Everybody thinks, that the trees in the Northern Hemisphere and these huge forests have a big role to play in sort of help mitigating the impacts of this CO2. The oceans actually play a much bigger role, and the Southern Ocean in particular. The Southern Ocean takes up 25% of man-made CO2 emissions that are emitted into the atmosphere. That's a quarter of all CO2 emissions put into the atmosphere the Southern Ocean is taking up, as well as 70% of the excess heat that is generated by the accumulation of those emissions in the atmosphere. So understanding the Southern Ocean, how it works, why it does such a good job of taking up this excess CO2 is really important, and what the sort of tipping points are on the ability of the Southern Ocean to keep on doing that in a climate that's changing. SOCO was sort of developed to try and look at that. We've taken advantage of our geographical positioning, so we kind of have decided to take a multidisciplinary approach to trying to understand the Southern Ocean.
Annually, researchers deploy gliders in the sub- and Arctic Ocean to measure stratification, or the vertical layering of the ocean. By using high-res ocean biogeochemical models, scientists are able to investigate physical and biogeochemical mechanisms that may explain the sensitivity of the Southern Ocean carbon cycle to climate change.
Ocean gliders are kind of a bit like drones that you see in the atmosphere all the time. They are profiling the ocean. Inside the glider, they can change their buoyancy. So the glider, which looks a bit like a plane, makes itself heavier so that it sinks, and it makes itself lighter so it rises. So the glider does these yaws, and it goes down to 1,000 meters depth. When it comes back to the surface, it has a iridium mast, which is essentially, it has a GPS on it. It tells us where it is, and it sends some data back to us. So we are able to then send some commands in return to it and say, please sample like this or sample like that. Gliders have multiple different sensors on them, which is great because it means that we can look at multiple different processes happening simultaneously together.
Learnings from the research are used to support the National Research Consortium that is developing a South African Earth Systems model with a special focus on improving climate projections in the Southern Hemisphere. Beyond the science and technology, SOCO offers young South African scientists from historically disadvantaged institutions a stimulating, challenging, and inspiring platform from where to build their skills in numerical modeling, machine learning, big data science, and analyzing complex systems in order to grow experts in this field.
Be able to ask good questions. I think that's what science is about, because knowledge is everywhere. And I think that being able to distill what's a good question and what's not a good question, and when you're faced with a complex problem, where do you start? And how do you think about it? So I think there's been a sort of a intellectual development about how to think about questions, and also meeting people that are very big in the field and sort of seeing how they think about things.
SOCOS celebrates its 10th anniversary in 2020 and has been able to pioneer ocean robotics in the country and build an interdisciplinary approach to explain the links between carbon and climate. The program has developed several new facilities specializing in robotics, biooptics, biogeochemistry, geotraces, and CO2, and in turn have created opportunities to design and innovate in an uncharted field.
Our research niche is understanding fine-scale dynamics, and for that we needed capability that was able to make the measurements at the scales that we needed. Because we've sort of now got to the point we've achieved the goals of using it in support of our research, we're now expanding beyond the research needs to address societal needs outside the science. We have developed a new PCO2 sensor to measure CO2 in the ocean, which is probably one of the best ones available globally. That was developed here by our engineers, and we've tested it in the Southern Ocean. We are using it as part of our research. We are now starting to market it globally, and we've sold our first 2 units to an Ocean Institute in Germany. So that's an area where we've gone from, again, the value chain of going from basic research towards innovation. And that innovation is about developing our South African intellectual property, really, and using that as a platform to start local manufacturing of advanced high-tech equipment.